Good morning, everybody. Sorry I couldn't be here today, but we don't want to install that right now. When we finished class on Friday, we had been doing stuff. We were talking about doubling time for things that had exponential growth, and it might have been something like this. 2 equals 1 plus, I don't know, let's do something like this, to the 12t. And we were trying to figure out what this value of t was, and to do that, we had gone to the graph. Let me actually do that right now. And we would type in both sides of that equality, and we would hit graph. And this graph would represent the amount of time that it takes to double. And currently, or at that moment, that was all we could do to solve this problem. Because unlike everything else where you have, like if we wanted to undo this division by 12, we would multiply by 12. If we want to do the opposite of addition, we subtract. If we want to do the opposite of x squared, then we take the square root. Those are inverse operations, and they undo other operations. And so when we come to this, there's not an inverse operation that we currently know, and for a long time there wasn't. That was just they had these things, they were tables that would help you answer these questions, and you would kind of have to go through the table, find your numbers, kind of like the power tables that we've used in the past, where you have like 2 to the first is 2, 2 to the second is 4, and they would answer that question using those tables. Well, thanks to technology now, we have those tables at our fingertips in your calculator. But the thing that we need to learn about is called a logarithm. That was a fancy L. Okay, these are logarithms, and the button that we use is the log button that's right down here on the calculator, right next to the 7. And so just like you would divide on both sides to undo multiplication or subtract something from both sides, we will do the log of both sides to undo this exponent, or basically to bring it out of the exponent. So here's the rule, here's the property. If you take the log of both sides, whatever's in the exponent will come out front. So it would be 12 times t times the log of 1 plus 0.05 over 12 is equal to the log, oh come on, equal to the log of 2. And then you just type this into your calculator. Logs have a base of 10, which we'll talk about in a little bit. And so what we want to do today is basically just get a general understanding of what a log is. And I have a Khan Academy set of videos that you may need to watch that may be helpful to showing you the basics of this. And I'll try to do a little bit of that here. But essentially, we want to know when we see something like log 2 of 4 equals question mark, what in the world is that telling us? Okay, and the logs have bases just like exponents have bases. And so if we had 2 to the x equals 4, that's something that we currently know because we're just familiar with these numbers. But logs are a little less intuitive for us. And so they take a little extra time to get to know them. And so what a log is meant to do is to help us figure out the answer to this question. 2 to what power equals 4? And we write that, so the base of the exponent, remember bases hold things up, so the 2 holds up the x, and the 2 holds up the log over here. The base stays the base, and the other 2 change places. Log base 2 of 4 equals x. The base of the exponent becomes the base of the log, and the other 2 things change places. The exponent, the x in the exponent comes out of the exponent. We don't have an exponent anymore. And so something that I always say is that a log is an exponent. The answer to a log is an exponent. It tells us the exponent. It answers the question, what do I have to raise 2 to get 4? And we know that the answer is 2. Log base 2 of 4 equals 2. And that's a good way you could remember it. And what you need to know about the calculator is that when you hit log, just a regular old log, it has a base of 10. And for a long time, you just used, there was this change of base formula, which we may use as we solve, but your calculator also has the ability to use a base that isn't 10, which is what you would need for this situation right here. We want to also, like with things like this, 2 log base 2 of 4, I don't want you to just type this in your calculator. I want you to know what it's asking, 2 to what power is 4, and you know the answer to that. You don't need your calculator. Now, when they do get a little more complicated, and maybe you do need a calculator, let's see how to get to a log of any base. Now again, we are in math class and we like doing math, so we're going to go to that button on our calculator. It has all the good things. You hit math and then hit the up arrow. And where it says log base, parenthesis, you want to choose that. And it will give you a little blinking cursor for that down there. You put your base in, 2. Put the other thing in, 4. And the answer is 2, which you already knew the answer to. The way I remember that this log has a base of 10 is I always do log of 100. I know the answer is an exponent. Log of 100 is 2. Why? Because the base is 10. 10 to what power is 100? The answer is 2. And I like to have cues in my mind that remind me of what things like log mean. If you don't use it a lot, it's kind of hard to remember. But if you can type in log 100 in your calculator, boom, it will give you the answer to, and hopefully you'll realize the link between 10 and 100 and 2. 10 squared is 100. So the answer to your log is the exponent. And it gets a lot harder when you do you're like, what power do I have to raise 10 to get 110? That's a really hard question. It's a number bigger than 2, way smaller than 3, so closer to 2, but what is it? Boom, your calculator is capable of telling you that. Okay, and we just want to know when it asks us a question, we want to be able to understand what it's asking us. So for example, I'll do a couple questions from each section. If you have log base 4 of 4, what is that asking us? Well, 4 to what power equals 4? You know the answer to that. The answer is 1. Khan Academy is excited for us. So the first section that you have to do, these are more basic ones. You could use the power tables that you have if you still have those. But mainly we want to know what this is asking us. 7 to what power is 343? And so I hope that you're starting to see that these will be useful if I give you an equation that looks like that, 7 to what power is 343, that you can use a log to get this x out of the exponent, and it would look something like this to figure out the answer. So what power do I have to raise 7 to get 343? I think the answer is 3. Khan Academy agrees. Good for me. Okay, let's do a little more advanced version. Now, I assigned all these videos, and I assigned all these videos, and I assigned the articles as well. But mainly, I want you to, get through this. And if you feel like you understand it, you can jump into the exercises. If you don't, I want you to watch those videos for sure and just go through them. 12 to what power equals 1? And you may at first think, I have no idea what this is. But we have this other rule, that if you raise something to a certain power, it always equals 1. Do you remember? Ooh, that's it. Okay, let's say that you had a moment of panic and you weren't sure about that one. You hit math on your calculator, go up to log base, and you do log base 12 of 1, and ask your calculator, and it will tell you it's 0. Real quick, you can skip this if you don't have this problem. If your calculator won't do a log base, it won't change the base for you. If you want to do log base 12 of 1, you should be able to just do log of 1 divided by the log of 12. Let me make sure this is correct. and it should give you the same thing. So this is a change of base. And you only would really need to do this for sure if your calculator won't do a log base for you. All right, let's do one more, and we'll call it good. This is a fun one. 4 to what power is equal to 1/2? 4 to what power is equal to 1/2? Okay, if you were to raise this to, well, if we want to turn this into a fraction, what happens if I have a negative exponent, like -1? I'm going to do 4, or 1 over 4 to the first power. So if the answer was -1, then it should equal 1/4. But that's not right. We want to do the square root of this. What's the exponent if you want to do the square root? 0.5. So I'm betting the answer to this is -0.5. If I raise 4 to the -1/2 power, I get 1/2. And let's see about that. Okay. So math, I'm going to go up to log base. Okay. And remember, as you do these, I want you to be trying to understand what the log is actually doing. But you can also use your calculator to check these. But most of them should be things you can do in your head. And there it is, -0.5. One time, let's just really quickly check this. Log of 1/2 divided by log of 4. Let's see. Again, it tells us -0.5. So even if your calculator won't do this, no panic. You can do it. Set it up like this, and then say, okay, calculator, you failed me, but I can still accomplish the goal, -0.5. And that's that. Y'all have a great day. I'll see you tomorrow.